Welcome to my channel. Today we are talking about Riverpod state management in Flutter. If you have built anything in Flutter, you have undoubtedly run into this frustrating scenario. You attempt to access your state using the standard provider.of context inside a modal route or during the initial state lifecycle, and boom, a runtime crash known as provider not found exception. Why does this happen? Because Flutter's context lookup travels upwards through the widget tree. But if your context is created at the wrong level, it sees absolutely nothing. This runtime fragility is the classic Flutter state management trap. Today, we are resolving it completely at compile time using Riverpod. To understand why Riverpod exists, we must analyze the structural limitations of its predecessor, Provider. Provider relies directly on Flutter's inherited widget architecture under the hood, which mandates that all your stateful objects must live directly inside the widget tree itself. If you want to share state between two distant screens or sibling pages, you are forced to hoist that state up to their nearest common ancestor, which is often the absolute root of your application. This unnecessarily clutters your widget tree, triggers massive cascade rebuilds, and tightly couples your pure business logic to your visual UI layout. Riverpod is an anagram of provider, representing a total architectural rewrite from scratch by the same creator. Instead of burying your stateful objects deep within the widget tree, Riverpod defines providers as global, top-level constants. Now, global variables usually represent an anti-pattern in software engineering, but Riverpod providers are actually read-only definitions. The actual runtime state is stored securely inside a centralized provider container wrapper that sits at the very root of your app within the provider scope widget, allowing safe, scoped access completely independent of Flutter's build context. To consume this global state inside our user interface, we replace Flutter's traditional statless widget with Riverpod's specialized consumer widget. This modification exposes a new parameter in the build method, called widgetRef. Unlike the classic build context, which merely represents a coordinate in the widget tree, widgetRef is our direct programmatic interface to the global provider container. By calling ref.watch on our counter provider, we set up a reactive dependency that surgically rebuilds only this specific widget when the underlying counter state increments, leaving the rest of the UI untouched. Where Riverpod truly separates itself from other solutions is its elegant handling of asynchronous network data. In vanilla Flutter, managing loading animations, error messages, and successful data states for a single HTTP endpoint requires writing verbose, error-prone boilerplate. Riverpod introduces Future Provider to handle this automatically. When you watch a Future Provider in your UI, it returns an async value union type. This compiled structure structurally forces you to implement branches for the .when state machine, covering data, error, and loading states, completely eliminating unhandled async errors at compile time. In a production-ready mobile application, you cannot allow stale, inactive state to continuously consume system memory. Riverpod elegantly addresses this lifecycle challenge using the .autodispose modifier, which automatically disposes of a provider's allocated state the exact moment all consumer widgets unmount from the screen. Furthermore, when you need to pass dynamic arguments, such as a specific product ID, directly into your data fetching logic, you can append the .family modifier. This creates dynamically cached instances of your provider for every unique parameter passed, handling garbage collection cleanly under the hood. Because Riverpod's state definitions are entirely decoupled from Flutter's rendering pipeline and build context, writing automated unit and widget tests becomes incredibly clean and fast. You no longer need to configure complex mocking frameworks or instantiate mock widget trees to verify your business logic. Inside your Dart tests, you can initialize a standalone headless provider container and utilize its overrides array. This allows you to surgically mock a real network provider with a mocked data source or fake repository, executing tests entirely in memory with maximum isolation. Thank you for watching this video. Please subscribe and follow.